Welcome to the Commercial Lighting Commissioning Technician course. Now we can review some electrical basics. The electrical voltage commonly used in buildings is alternating current, or AC, in a basic form. There will be a wire which carries voltage, known as the hot or line wire, and then a wire which completes the circuit by returning the voltage, known as the neutral wire. The standard voltage in North America is 120 volts AC and is measured using RMS. It will make 60 complete cycles between positive and negative voltages every second, and therefore is further designated as 60 Hz. In all circuits, ground wires are required for safety purposes and provide a safer return path should the neutral wire become damaged. Split-phase systems are commonly used in residential or light commercial systems. In these systems, there are two line wires and a neutral. This allows devices to either use 240 volts if they are connected to the two line wires, or 120 volts if they are connected to a line wire and the neutral. Please note again that the ground wire is required for safety, even though it is connected to the neutral at the electrical panel. Three-phase systems are used in most commercial and industrial applications. In these systems, the electricity is moved with three line wires and one neutral. This provides a balanced method of obtaining either 208 volts across two line wires or 120 volts across one line wire and one neutral. Depending on the industrial or lighting equipment requirements, you may also see three-phase systems which provide larger voltages, such as 277 through 480 specification. Here is a quick reference for the wire colors specified by the electrical code to be used on each wire used in an electrical system. This specification must be followed so that electricians may safely work on and operate the electrical system, and very few substitutions are permitted. In a single-phase system, just the black, white, and green wires are used. In a single split-phase system, the red wire is added. Depending on the application, the ground wire is permitted as bare copper, without an insulator. Emergency power systems are in place in most industrial, commercial, and some residential systems. These provide a secondary source of power to take over certain circuits in the case of a power failure, when the electricity on the primary source is disrupted for a period of time. Emergency transfer panels will switch over circuits from the primary system to a secondary generator or battery bank in this case. Emergency circuits that would be connected to this system may include selected lighting fixtures, fire and safety systems, and elevators. Depending on the electrical characteristics of the lighting load, it may be required to provide a lower voltage, such as reducing the standard 120 volts down to 12 volts for a miniature reflector lamp. There are essentially two different ways of doing this. The first method uses a transformer and is referred to as magnetic low voltage. Whatever waveform is present at the input, such as 120 volts 60 Hz, will be simply and proportionately reduced in amplitude at the output. The second method uses a combination of electrical and electronic equipment and will provide a regulated output regardless of variations on the input. Although this does appear to be a more reliable method, there are more considerations to be made when used for light dimming, which we will discuss next. Thank you for watching.